Hi everybody, Mr. D here, just checking in. Looking to do a little bit of work with respect to um, calculus once again, this time with first principles, as well as an application of calculus. So here we are, this is a paper 2 question, that's important to note. GDC is in play here. So we're given a function, and the first thing we're asked to do is expand a binomial to the exponent 3. Then we're asked to find its first derivative using the limit formula to show that the derivative is what we would expect to see using the power rule. Then we're asked to do a few other questions, find the tangent of the curve at a given point parallel to a point Q, and asked to find the coordinates of Q. D is what's the interval of decrease, and E is the range of the gradient, in other words, the derivative of F. So we've got a few questions to do here. Let's start with the first one. So what we're trying to do here is expand x plus h cubed. There's a few ways you could do it. You can just grind it out and multiply x plus h times x plus h times x plus h, and that is a good solution, although a time-consuming solution. So because time is of the essence, let's see if we can use a technique that'll put the formula booklet in play. And as we know from the formula booklet, there is a formula that allows us to find the binomial expansion using choose notation or combinations notation. And because our GDC is in play, we can actually find these coefficients quite readily. If not, you can use Pascal's triangle with the coefficients 1, 3, 3, 1. We know that the number of terms in the expansion of something with an exponent 3 is going to be 4 terms. It's always one more term than the exponent indicates. And then we basically take the a and b values, in this case here x and h, and count down with one of them. We'll start with x. The order doesn't matter. You can start with h and count down, but we've started to go with x cubed, which is the highest degree, and then down to x squared, x to the first, and x to the 0. And then from the other end, we count down from the highest degree of 3 with this particular term h. So we have h cubed, h squared, h to the 1, h to the 0. And then we do some housekeeping and simplification, and we end up with this as our expansion. Moving ahead, what's interesting about this question is it's quite likely that we'll utilize part A, and in actual fact, we will. This is a trademark or a hallmark of certain IB style questions where you put the prior solution in play when it's applicable. So in this case here, we're asked for the basic first principles definition of a derivative. So we're going to take f at x plus h, which means wherever there's an x in the given function, we're going to replace it with x plus h. And then we're going to subtract the actual function as it appears. So here we go, I've done the substitution. The x plus h cubed, I've gone ahead and substituted this expansion in for x plus h cubed. Then I subtracted 4 times x plus h plus 1. That 1 is important. There isn't an x there, so no need to substitute anything in, but you do need to include the plus 1. And then we're going to subtract the function as it appears in the given question and divide all that by h. Then we have to be careful using distributive property and making sure that we carry through the signage through that trinomial, and same with this signage here, minus 4, carry that through this binomial. And if we've done that carefully, every term that does not contain an h should find a partner of opposite sign. What do I mean by that? Well, we have a positive x cubed without an h. That means there should be a minus x cubed that doesn't contain an h. And lo and behold, there you have it. Similarly, we have a minus 4x. That means there should be a plus 4x. We have a plus 1. There should be a minus 1. And that's important to note because every term that remains from the substitution should have an h, so we can common factor. Upon common factoring the numerator, you'll notice that it has a mate h downstairs in the denominator. H divided by h is just a fancy version of 1, so they divide out. Then we can set h equal to 0 in the remaining terms, and you'll see that this doesn't have an h, but this does, and this term does not. So the terms that contain h will become 0, and we're left with 3x squared minus 4 as the first derivative, as required. So moving ahead to the next page. We're asked to find the tangent line equation at a given point. So to find the equation of any line, you need a slope and a point. We're given the point, p, 1 comma negative 2, but we don't have the given slope at that point, 1 comma negative 2. From the prior question that we just proved, the derivative is 3x squared minus 4. If we substitute in the x value and simplify, we'll come up with the actual rate of change at that point. In other words, the derivative function value at 1 is negative 1. So now we have our m, y equals mx plus b. There's our m. We don't have a b, but we do have an x and y candidate. So we're going to simplify and come up with the actual tangent equation as y equals negative x minus 1 at the given point p. 15 was an interesting question. Just going to refresh our memory here. We're going to look at number 15D. We were asked to find the areas of decrease for this particular function. So we're going to go ahead and find the critical points. In other words, where's the first derivative equal to 0? We have the first derivative from the prior question in part B. Set that equal to 0. Construct a sign diagram for each of those critical values. And we really don't even need our graphing display calculator for this, because we know that the interval of decrease is contained by two values, p and q. So therefore, we can assume that this indeed is the interval of decrease. And I've made that explanation there. And then lastly, we were asked to find the range of the first derivative. You go ahead and substitute in this value, 3x squared minus 4, into the function, graph it, and then you'll notice that its minimum value is at negative 4. Therefore, the range is any real number greater than or equal to negative 4. So I hope that helps understanding. Stay tuned for more videos.